Hi, I'm Erik Brynjolfsson, Director of the Stanford Digital Economy Lab and a Senior Fellow at the Institute for Human-Centered AI and the Stanford Institute for Economic Policy. I am so delighted to welcome you all to our conference on AI and the future of work. I believe we're in the early days of an AI-driven restructuring of the economy, and today you're going to hear a remarkable set of researchers, business leaders, and policymakers discuss the implications for AI and for the workforce. I also hope you'll join the conversation by asking your own questions. And now it's my pleasure to introduce Stanford University President, Dr. Marc Tessier-Lavigne, who will kick off the conference. Mr. President, take it away.
Great. Well, thank you so much, Professor Brynjolfsson. I'm really delighted to welcome all of you to the AI and the Future of Work conference. Although I wish we were gathered in person today, I'm really pleased that so many of you have joined for today's virtual program, which is featuring a truly remarkable lineup of speakers. I'm also mindful of those who would have liked to have joined us today, but could not due to their job situation, their health, caregiving responsibilities, or other circumstances. This is a difficult time for many. We face a wide range of challenges right now, from the coronavirus pandemic to tackling racial injustice to a divisive election season. But the tremendous upheaval we face also makes this a transformative moment. Our world will be different when the coronavirus pandemic ends. How we work, how we learn, and how we live, all of it will change as a result of what we're experiencing now. This conference, focused on the impact of AI and digital technologies on productivity, business, and policy, comes at a pivotal moment. Now is the moment to search for creative solutions to help us to shape the world that emerges. Now, as I look to the future, I've been thinking about the great challenges we face and the lessons we can apply from this experience as we work to solve them. There are two lessons in particular that I think will transform the role of universities and the contributions we make to the world in the long term as a result of the pandemic. The first is an increased focus on accelerating the application of knowledge. When COVID-19 reached California in the early spring, Stanford researchers rapidly pivoted to deploy our resources to respond to the medical, epidemiological, societal, and personal impacts of COVID-19. Members of our community worked effectively and efficiently with external partners to develop diagnostic tests and hasten trials of possible therapies. Outside of healthcare, we also had researchers working on insights and interventions to improve remote education, reduce the spread among incarcerated populations, and much more. This model of accelerating the application of knowledge has promise across countless fields of research, and artificial intelligence is certainly one of them. I believe we can work together to amplify our contributions and derive new, large-scale solutions to our great challenges. The second way that I think our university and the world beyond it will be fundamentally changed is through this intense experiment with moving our operations online. From remote education to telehealth to work from home, we found new ways to learn and work this year. This unprecedented move online has tremendous potential to make education and healthcare more accessible and equitable long after COVID has subsided. And the lessons we learned from this experience with remote work have the potential to lead to more flexible, connective, and productive work environments when we emerge. The challenges we face are difficult. In particular, to reap the rewards of equity and access, we need digital democracy. We need universal access to broadband and technology for all. But I believe that working together and making ambitious plans, we can create a better future. Both of these points of transformation, accelerating the application of knowledge and the great move online, intersect in the field of artificial intelligence. At Stanford HAI and in the Digital Economy Lab, our researchers are thinking about the ways in which AI technologies are profoundly changing how humans live and work. Many of us now use AI every day in our workplaces and our homes in ways that we couldn't have imagined even a few short years ago. And we're only at the beginning of what may be a radical transformation in how we live our lives. AI has the potential to change society for the better in so many ways, from promising medical applications to vastly safer cars. But the advance of artificial intelligence also creates risks, from job insecurity to the potential for bias in machine learning. Our success in creating a future in which the benefits of AI are shared widely depends on the work we do now to shape that future. At Stanford, our approach is to put humans at the center of AI development, to ensure that we're developing tools and policies that will serve, augment, and complement humanity, not replace or divide it. We focus on the ethical implications of new technology to help ensure that human values do not get lost amid the fast pace of technological innovation. And we bring in expertise from all corners of our campus, drawing on thought leaders in economics and law, literature and philosophy, neuroscience and medicine, to provide insight into how artificial intelligence can center on human needs and interests. The launch of the Stanford Digital Economy Lab at HAI will accelerate this mission. This new lab, led by Professor Brynjolfsson, amplifies our efforts to examine and understand the impact of digital technology and develop tools and insights that lead to a tech-driven economy that works for everyone. We're thrilled that Professor Brynjolfsson has joined our faculty, and I'm tremendously excited about the work underway in the Digital Economy Lab and at Stanford HAI as a whole. In this moment of uncertainty, this work gives me great hope that when we emerge from the pandemic, we will be working toward a more equitable future with better quality of life for all around the world. I want to thank the conference organizers in Stanford HAI and the Digital Economy Lab for putting together today's outstanding program. And thank you all once again for joining us today.
Thank you so much, President Tessier-Lavigne, for those very thoughtful remarks and reminding me why I'm so thrilled to be here at Stanford and have an opportunity to launch this new Digital Economy Lab. Now I'd like to introduce my partner in this venture, the Digital Economy Lab's Executive Director, Christy Coe. Christy's going to be emceeing today's event. Christy, over to you.
Hi, everyone. Welcome. I'm excited to be at Stanford building this lab with Erik and helping MC today's event. The event page where you're viewing this stream has links to everything you need: the schedule, the list of speakers, and the link to the Q&A. We're taking questions from the audience. The Slido event number is 9,000. We encourage you to participate in this discussion. We will try to get to as many of your questions as we can. And yes, the sessions will be taped and available right after this event on YouTube. You'll be able to find that on our website and on the HAI website. If you're tweeting about this event, please tag us on social media at DigEconLab, and you can use the hashtag StanfordFOW. Thank you so much for being here, and I'm excited to be part of this event. Erik?
Thanks, Christy. As we launch the event here, I'd like to just say a few remarks about why we're doing this and why the digital economy has taken such a big role in what we're looking at. You know, we're in the middle of a fundamental transformation of the economy. Some really profound things are happening. You can see that, for instance, in labor markets, there are more billionaires, more millionaires than ever before. But there are also more and more people being left behind who aren't keeping up. We see just the remote work that we're doing right now, all of us online. At the beginning of the year, about 15% of Americans work remotely. According to research we've been doing, it's over 50% now. We see it in capital markets, where 7 of the 7 most valuable companies on the planet are basically digital companies, and most of their assets are intangible. And we see it in the kinds of goods and services that we're consuming: free goods, free services that aren't captured in our GDP statistics, and we're gonna have to reinvent those as well. Now, these profound changes that are going on have a lot of causes, but the one that we're gonna be focusing on is the digitization of almost everything. And bits, the basic unit of digitization, are fundamentally different than atoms. They have 3 properties that we don't see often when we talk about atoms. They're essentially free, they're perfect, and they're instant, meaning that they have 0 marginal cost. Each bit is or item made of bits is a perfect replica of other items that they're made the same way, and they can be transmitted instantaneously across the company, across the country, across the globe. These characteristics give a whole new set of economics. They lead to new business models that are creating unexpected winners and losers. At the same time, we also have a tremendous explosion of new tools, new types of data analysis, new techniques, new projects that data scientists can work on. And perhaps most importantly, machines are beginning to become intelligent. And that is what we've started calling the AI awakening. So let me share my screen here to talk a little bit about this and about how AI is becoming a general purpose technology. That's an important class of technologies. Earlier general purpose technologies included the steam engine and electricity, and each of them led to cascading changes throughout the economy, big changes in living standards, but also a lot of disruption. You could make the case that AI is the most general of all general purpose technologies, because after all, what could be more fundamental than intelligence? When I was visiting Google's DeepMind headquarters, I saw a quote there from Demis Hassabis, one of the co-founders. He said, "Our goal is to solve intelligence and then use that to solve all the other problems in the world." Well, that's pretty ambitious, but it's certainly true that if we successfully have machines that are intelligent, we're going to be able to solve a lot of the problems in the world. We're also going to be faced with a lot of new challenges. And we are now crossing an important new threshold. If you look at different capabilities of AI, for instance, image recognition, as recently as a decade ago, machines just weren't very good at recognizing images. But then the ImageNet recognition challenge that Fei-Fei Li helped and others helped put together here provided a foundation for where researchers could look at the different kinds of tools and see if they could improve that. And now, in many applications, machine vision systems are as good or better than humans. Now, when it crosses that threshold, that opens up a lot of new possibilities for entrepreneurs and managers to substitute machine intelligence for human intelligence. And we're seeing that not just in labeling images, but in many other applications, all kinds of problem solving. Of course, many of us are starting to use voice recognition systems with our phones or our Google Assistants or other tools. And they're not perfect, but we're in this interesting, I'd call it 10-year period or so, where we went from not talking to our machines at all to routinely communicating with our machines, first in simple conversations and then increasingly more complicated ones. We're also using these tools in R&D and fraud detection, in customer recommendations and product recommendations, in traffic management, and many other applications. There's something of a gold rush going on right now to see where these tools can be applied. And there's a pretty broad class of possibilities. Almost anything where you have a lot of data that provides inputs and a lot of data for a classified set of outputs is a candidate for these kinds of machine learning systems. And that's opening up a lot of potential. But how does this affect wages? How is this going to affect the economy? Well, there are at least 6 forces at work. The one that most people think of first, frankly, I think of first, is substitution. Can these tools replace some of the things that humans are doing? But if you dive a little deeper, you see that there are many other ways that machines can affect work. And in an article with Tom Mitchell, we describe these other possibilities, including effects on supply and demand, and perhaps very importantly, complementarities, the ability for machines to not simply replace work or substitute for it, but to augment it and allow humans to become more important and more valuable. And that's something that's grown over time as more and more opportunities are created for machines to help humans do their jobs. And I think ultimately the one that's going to have the biggest impact is the ability to do new tasks via invention and transformation, the re-engineering of work, the restructuring and redesign of the entire economy. Now, in related research, we've looked at which tasks can be performed well by machine learning and other types of artificial intelligence. And the first thing to bear in mind is that we're very far from what we could call artificial general intelligence. That's what you see in Hollywood movies where machines do the full breadth of what humans can do. And that's not likely anytime soon, maybe not ever. But we do see narrow artificial intelligence that can do specific tasks as well or better than humans. I just showed you a few examples of that. So we set out to see which tasks in the economy were most likely to be affected by machine learning, which ones were in fact most suitable for machine learning. We looked at 950 occupations, and within each of those, there were about 20 to 30 distinct tasks for a total of about 18,000 occupation-specific tasks. And for each of them, we evaluated their suitability for machine learning. And what we found was that for different jobs, there was no occupation where machine learning just ran the table and was able to do everything. For instance, a commonly cited example is radiology, where machines have gotten very good at, as I mentioned earlier, image recognition. And there are papers that come up seemingly every month in Science or Nature or other journals describing how medical imaging can be done as well or better by machines. But that's not the only thing that radiologists or other people in that profession do. If you look at the set of tasks according to ONET that describes the work of radiologists, there are 27 tasks. Here are 7 of them. One of them, for instance, is administering sedation consciously. And that's not something you'd want a machine to be doing. Conducting physical exams, coordinating care with other radiologists and other doctors, counseling patients after exams. These are all things where humans have an advantage. That said, there are certainly some occupations where there are more tasks that are suitable for machine learning and others where there are fewer tasks. If you look at the 950 occupations on this scatter plot here, you can see that the ones with the higher wages are towards the right and the ones with the lower wages to the left, and the ones that are more suitable for machine learning are near the top. And there are occupations in all 4 quadrants here, but you do see a pattern. For instance, cashiers, a relatively low paid job, have a large percentage of tasks suitable for machine learning. Now, pilots also have a fair number of tasks suitable for machine learning, even though they're fairly high paid, but there's a general downward slope indicating that on average, in our economy today, more of the low paying jobs have a lot of tasks that are suitable for machine learning. And I couldn't help taking a peek at where my job lays. It's not paid quite as much as pilots, but for now, not as vulnerable to having machine learning replace many of the tasks, or for that matter, augment them. The fundamental thing to understand about these technologies is that while digital progress does make the economic pie bigger, it allows us to have better health, greater wealth, solve all sorts of problems in the environment and create new goods and services we never had before. There's no economic law that everyone's going to benefit proportionally. In fact, there's no economic law that everyone or even most people will benefit at all. It's possible to have a technology that makes the pie bigger, but have most of those benefits go to a small percentage of the population. Through most of the past couple of 100 years, that's not been the way it worked. In general, living standards rose across the board. At least they did up until about the end of the 20th century. For the past decade or two, we've seen a change in that, where a lot of the benefits are going to a very small group of people. And although productivity is going up, the median income, the people at the 50th percentile and below, have not been keeping up. Andrew McAfee and I call this the great decoupling, and you can see it here in this chart. The red bar at the top is output per hour, or productivity, and that's continuing to rise. It'd be great if it rose even faster, but we see a continuing growth in overall productivity, how much output we can create for every hour worked. But the blue line has diverged from it. Up until the year 2000, they were closely linked, and more wealth in the economy also meant that median income, the person at the 50th percentile, was capturing a proportionate share of that. But now those lines have diverged, meaning that people in the bottom half of the income distribution aren't keeping up to the same extent as they did in the previous century. Now, that's something we need to work on, and there are a lot of challenges there are a lot of reasons for this challenge. The fundamental reason is that while digital technologies continue to accelerate, our skills, our organizations, and our institutions are lagging. And to me, that means that we need digital transformation. The answer is not to try to slow down the technologies, is to speed up our adaptation, understand better the types of transformation that will create more broadly shared prosperity, and understand the underlying drivers of these fundamental changes. So that's why we created the Digital Economy Lab, a world-class community of these best researchers, the data sets, industry partners. There are a lot of people at Stanford and around the world that want to work on these problems, and we want to create a hub for them to coordinate, share data, and connect with industry partners to learn better what the problems are that can address. It's an interdisciplinary research group, and as we mentioned, it's based here at the Stanford Institute for Human-Centered AI, and it's co-sponsored by SEPR, the Stanford Institute for Economic Policy Research. We currently have 4 main areas of research. The first one is the one you're hearing about today, the future of work. We're also looking at new digital business models, data-driven decision-making and management practices, and new ways to measure the economy, because the old ways simply don't capture most of the benefits of the digital economy. We hope you'll all get involved with it and learn not just today and join this event and our future events, but also sign up for our newsletter, become an affiliate, and of course, visit our website. And that's at digitaleconomy.stanford.edu.